Ladies and gentlemen, I thank Dr. Gidado. Yesterday, when I was coming, I was asking someone if Dr. Gidado is still on board. Sure, yes. Without her, this conference cannot go easily. So I thank her for her strength. Actually, her success, tremendous success in crop biotechnology cannot be forgotten. We already shall etch her name in gold in that field. And that was the main reason when Dr. Pupoala left, I had to ask her to please come on board and fill the gap until someone comes. But if she grows so well, she can do well there and leave crop biotechnology. Ladies and gentlemen, I do not have much to delay anyone here. But if you move on, animal biotechnology research and focus was the assignment given to me. And I decided that I speak for Nigeria. And therefore, I had to add the Nigerian perspectives. I hope you like it. Because all our biotechnology that we know of cannot compare with what the white man is doing in his own country. But our own biotechnology is important to us. And we make do with what we are doing and what we are getting. And so that's why I felt that it's important that we know what we are doing and what the world is doing. I am not going to take you along the lane of what the white man is doing so much. Though I have them, please can you move the slides? Everybody now knows what animal agriculture is and what animal biotechnology, what it involved. It started way back when the early man came. The ability to house an animal, they hunt to get animal, and when they cannot kill all of them, they keep them and rear them and don't want them to die. From there, they started manipulating the animals. That was the beginning of animal biotechnology. So next slide. Just keep going. Don't mind me, we'll have to keep the 20 minutes given to us. Are you moving?
Yes, sir.
Okay. Now, the background of animal biotechnology has been given. It started way back, but there are certain techniques that are far beyond animal selection, crossbreeding, and so on and so forth. By going back, going to the molecular techniques, using ultra high, infinite size microscopy to understand the nature of genotypes, the nature of DNA and the genomes. From there, man moved forward and able to capture the DNAs and see what the DNAs are made of. And they were also able to capture the regions of the DNA where the genes perform the action in expressing traits. And that has led to latest developments in the field. Next slide, please. But it all started with embryo manipulation. And that is an advanced reproductive technology, which everyone knows. Professor Peter Report, you know, when I joined you people in NAPRI way back in 1985, the leading technology then, animal biotechnology, was performed by NAPRI in the AI unit. And all of you were there, and we were in poultry, but we are coming to see the amazing developments. Yes, yes. So it started in Nigeria with the embryo technology, keeping semen in the cryopreservation form. But then, from there, we can see that even NAPRI is behind the times in terms of animal biotechnology achievements. So, the next slide. From there, it moved to in vitro fertilization. But I've been informed that someone who may be speaking today or tomorrow from Brazil may be touching on some of these latest developments in biotechnology across the world. So I'm not going to waste time on some of these, but you can see in vitro fertilization started with animals, and now it is in humans, because humans are finding it difficult to reproduce using in vitro fertilization, IVF, to produce children. And so what is going on in animals, they use animals as a test ground for human development. And that is why animal biotechnology is the milestone. The next slide. Wow. The next one is transgenics. In 2009, it was a new field in animal biotechnology, where you can go to an animal or a plant or a low animal and look at the genome and see what the genome is able to do, the section of that genome that is responsible for certain traits that we want to acquire and transfer it to a living animal. And that's transgenics. From one organism to another organism. And if, for example, some of the tables in table 3.1, you will see certain sites collected from a tiny animal or a plant and inserted in an animal, another animal, bigger animal, especially farm animals. And the farm animal will be responsive to certain corrections you want to achieve. Can we see the table? For example, for milk production, high milk production, you act on the rhizome of the human, extract and put into cow, and the cow will be high in a good composed milk, where you have all the nutrients and the ingredients and amino acids complete in the human and in the animal cow milk. Ordinarily, the cow milk may not be sufficient or in what we want, but having got it from humans, and that's why when you see milk being composed milk, artificial milk being retailed, you know you value it because they have, through more biotechnology, transgenics. They are collected from human beings because people have been complaining. Our children don't suckle again their mothers, and then so that everybody resource on milk. But these days, the milk we are now taken by the market is highly composed and so can sustain the intactness of the human baby. But this is in the cow, the modern cow's milk is completely rich and safe for human consumption. And so on, there is a place that from E. coli of mouse, the gene was extracted to increase and affect feed intake in the farm animal. And some other one, even from getting lysosome from the spinach, can also affect milk composition. Omega-3 from the pig, omega-3 can be used inside of the pig to increase piglet survival, and so on and so forth. Next slide. But the broad field of genetic engineering includes cloning, gene editing, gene knockout, and gene mining. These are very new technologies that I am interested in, that you can now clone in transgenics, discover a set of genes in certain DNAs, whether it is within the same species or another breed. You can now tell that gene is in transgenics. The next one is gene editing. It is now possible that certain animals, let's take the Muturu cattle. Muturu cattle, you know, is a very small animal, but you can edit its genes now as you are editing a literature. And so what you do is the scientists do is to reach to the DNA, the essential region, and look for a particular gene that is capable of giving high growth rate and body weight yield, and insert into the particular animal, let's say the Muturu cattle. And what you see is an improved body weight in a Muturu cattle. So it's a gene editing. So you can correct an abnormality, genetic abnormality in farm animals by means of the gene editing. The next one is a gene knockout. What is going on now is, for example, these large cows, the Bororo, the Bonangi, the Godali, and all those new cattle that were moved by the herdsmen with large horns, some are large-shaped. The genes for horn condition can be knocked out entirely in the genome, and it's happening right now across the world. And so you can ensure that if NAFDA and all the research institutions and universities and so on are given the opportunity and the correct funding, we may be able to have a population of the large horn cattle made poor, that is hornless, so they can handle them. They become friendly, you can keep them. So what scares people is their large horns. So gene knockout is the end thing now. The next one is gene mining, allele mining. We call it gene mining or allele mining. You look for a particular allele because in the native chicken that I worked with over the years, it was discovered most of the loci are filled with residual genes, the recessive genes, most of the loci. So what do we do? In order to work on these native chickens now, you have to mine alleles everywhere in all chickens and get those alleles that are responsible for dominant gene effect and then use it to replace what we have in the native chicken. These are the things that are in focus. Right now, next slide. Next slide. Now let's go to the Nigerian perspective because time is not on our side. Perspective for Nigeria. Of course, history tells us that the agricultural research institutes were established between 1924 and 1977. And out of these, there are 4 of them. 2 have mandates for fisheries, and 1 for animal health, and 1 for animal production. That 1 for animal production is NAPRI. The other 1 for animal health is NVRI. And then the other 2 are NIOMA in Lagos and NIFRI, where I happen to have chairman the board. There are 38 universities approved for agriculture and agricultural technology, out of which 5 of them are privately owned. And it is these the establishments that can handle animal biotechnology and other general animal agricultural technology. Next slide. There are notable achievements in Nigeria's animal biotechnology. You can see them. Of course, by the grace of God, in 1985, I was one of those recruited to serve with Professor Sakanuru, and we started and developed the Shika Brown. I thank God that Shika Brown was registered in 2000. Then there are also other ones, the Shika Brown, the FUNAB Alpha. Of course, by the grace of God, in 2018, I am in the committee that approved the registration of FUNAB Alpha because it underwent performance testing across the geopolitical zones. And I learned that others that are yet to line up for registration, the Croiler and so on and so forth, will be registered as soon as possible. So Nigeria is moving forward with developing own breeds. The University of Nigeria and Nsukka has developed from the pure native without exotic, have developed the heavy eco-type chickens. If you see the heavy eco-type chickens, they are as big or if not bigger than most exotic breeds around. But from using the native through selective breeding that lasted over the years. Next slide. Of course, Ibadan developed one other breed of pigs, OAU, that is agricultural research and training. NVRI has developed form and developed no vaccines on its own using its technology, and we are proud of the achievements of NVRI form. Next slide. There are private organizations like the Smart Farm, Real People Concept, Smart Farms. You have KP, WANCO, and so on. These ones are organizations based in this country that are utilizing high technology to develop what we want. Prioritizing Nigeria's biotechnology research development focus. I have said, and I'll keep saying that we have made these achievements so far, despite the lip service funding attention given to biotechnology research and development effort in Nigeria, to the extent that, if truth must be said, the nation, Nigeria, in all her capabilities, cannot afford to engage the heavy cost of organizing sustainable biotechnological studies, procuring facilities for manufacturing and value creations, and that we still depend on imported biotech products, food animal stocks, food crops, biomedical, and various equipment and machines over time. It has become expedient that we prioritize what the country can afford or handle, especially in animal agriculture, including stock, genetic improvement, and reproductivity, nutrition and management facilities. The next slides, can I see the next slides? The next slide, yes. This next slide is what we think that can take place in Nigeria. I want NAFDA to pay special attention to this, because NAFDA cannot exist in this second decade without having a dedicated funding and project that can get Nigeria moving. It's not just recording what people have achieved. Let NAFDA lead in achieving. Number one, how do we remove or shorten the horn by gene knockout to get a hornless or short horn cattle in Nigeria? Number two, improve milk yield. In Vision 2009, 2020, that was around 2009, our target was to ensure that the average milk yield of a cow in Nigeria should be not less than 5 kilograms per cow per day. So we want to emphasize that we improve from 3.0 to more than 7.0, and we can use it through gene editing, allele mining, and selective breeding. I'll tell you about selective breeding. When everything fails and we cannot afford it, so we go to selective breeding. And then for increase the body size per head from 150 to 350 kilograms for short horn through cattle, and so on. This is possible. How do we do that? Gene editing, allele mining, and selective breeding to raise milk yield body weight from the present less than 150 kilograms to more than 350 kilograms per cow. And what do you get? Larger size beef strength. And also improve the milk yield, because as at now, these animals we are talking about, the Muturu, the Keteku, even the Ndama, they don't have access or genetic ability to produce milk. But it's not possible through animal biotechnology. And so we can give them a capability for milk yield so that they'll become a very native strain that we created. And then you have the increased body size for this was African dwarf goat, the middleback goat, and other small size goats. At present, Nigeria, the red Sokoto, and all these animals that are so large size, fine. But when they come down south and other areas, they don't perform. And if you use them for breeding, it's a one-sided, no reciprocal breeding. When you want to use a large size Sokoto Godala and a small West African dwarf, who have experimented, one of my PhD students saw it. The embryo does not survive for one particular reciprocal crossing. Then we can do this for the small size of those goats from the present less than 15 kilograms to over 30 kilograms, and then you see large size goats that are possible through gene editing, allele mining, and selective breeding. Then we can also introduce milk yield in them, because goat milk is the best form of milk, natural milk in the whole world. Everybody knows the cost is about 3 or 4 times the cost of 1 kilogram of normal cow milk. And then we can give that making ability to the local ones. And also increase the kidding rate from 1 kid to 4 kids per doe. It is possible, because even there are some animals among the West African dwarf goats that can give you quadruplets. So we can look for the gene for the quadruplets and multiply it across through cloning. Next slide. Yes, the swine, of course, just to increase the litter size there are certain swine cells that give you less than 8 throughout its life in attaining parity. But with latest technology, you can get up to 16 and so on, and also reduce the excess marbling and back fat thickness. Major hindrance in those who consume pork is fat, and this can be eliminated. Even from genes from plants can do it. Then native chickens, of course, how do we raise the muscle? How can we increase the muscle growth? Through transgenics, gene editing, and so on. The same thing with the broiler. We need to develop the broiler native broilers, which can also be achieved through transgenics. Now, there are remarks. Genetic engineering applications, which have been listed, are very capital intensive to organize and sustain over time. Nevertheless, they take relatively short time to accomplish, lasting from 3 weeks to 9 months. More molecular genetics, genetic engineering processes, all of them will not take, one can take only 3 weeks, others will take 9 months highest, compared to selective breeding that can last a number of years. For example, it will take 15 to 20 years to achieve in cattle. If you want to really produce a new breed of cattle that will have ameliorated, you have made to become a new cattle breed, it will take that. It will take 10 to 15 years for swine and small ruminants if you really want to achieve something that is formidable. And then for 5 to 10 years for poultry to meet the targets. Actually, in poultry, I blamed the producers of FNAP Alpha for taking only 3 years and for 3.5 years. I said it is not enough because it will not last, because the genes have not stabilized, and it will take you more generations to achieve stabilized frequencies of the genes that we want. And that is why when some of us went for performance testing, we saw some of them sitting on eggs, some laying white eggs, some laying brown eggs, but they have good size in the egg size. But we have accepted it, provided, because Professor Adebabo promised that they will still continue to work to improve. After all, the ISA Brown, a French breed, was introduced into the world in 1978. Today, they are still working on ISA Brown for it to reach global competition. So no new breed, a manufactured breed, can be stable. You keep working on it. Do you understand me? All live products of molecular genetic feeds must be subjected to quantitative genetic tests in a milieu of Nigeria's ecological and climatic environments outside the greenhouse setting. You see, when you bring out the new genotypes, which you have used gene mining, gene editing, transgenics, cloning, and so on, all forms of genetic engineering, they do well within the greenhouse, very, very well. But when you take them outside to compete with others, you take them outside to an environment that are different from that of the laboratory, you are bound to see the interaction, genotype environment interaction, and that is the real test. Someone ago, he told us, when I was on the sabbatical at Calabar, a colleague in the Department of Genetics and Biotechnology, who was working at cocoa research, and he founded 16 accessions, new genotypes of cocoa. And so the Honorable Minister employed him immediately as a special assistant. So he came up to Abuja. So when he now went about to teach it to farmers and gave them those new 16 sessions, the farmers didn't know that those differences were manifested only within the greenhouse, where everything is under control. So when these 16 genotypes, new genotypes, were taken to different fields, they just turned out to be the ordinary cocoa they knew. So the issue is that the world is advancing too fast in the laboratory, but they are not testing the animals really in the field. And they must pass through quantitative genetic testing. Next slide. So, conclusion. This is what I've been discussing about. But I want to say there are concerns about the use of animal genetic modified organisms, which may include uncertified potential human health effects. That's one of the major concerns about these GMOs, because we eat the animals, we use their products, we use some of their products even for medicine. But the concerns about permanent effect that may come from their continued use are yet to be ascertained fully. Now, effects, we have to consider also the effects of the environment in which they are, which I've just finished talking about, and on the animal's welfare and natural intactness. A situation where you put the gene, the tissue of a frog in cattle. Would you like to know that part of frog is in that cat and then you eat it? You wouldn't. And you have altered intactness, natural intactness of this animal. That is a major concern. And where E. coli, the gene in E. coli is used to change certain things in the meat you are going to eat, you are afraid. In the early days, when I was starting this breeding work in broiler, I went to the market and sought fish scrap, ground it, it contains bone and some dry fish, ground it, and used to substitute fish meal. After 8 weeks of feeding the broilers, when the broiler was slaughtered and were eating it, it was tasting fishy. Try it yourself. It will taste fishy. So, fortunately, Nigeria has established the National Animal Biotechnology Development Agency and National Biosafety Management Agencies, which are mandated to handle all biotech development and biosafety regulatory matters in the country. Both of these organizations, agencies, are noted to be very active in the pursuits of their statutory assignments. I believe they are doing their work, but the hindrance is funding, the epileptic funding situation. They have an elastic mandate, a mandate that can fill 2 pages, but not even one of them could be funded properly. That is our problem. And I believe that with more pressures, advocacy on this biotechnology, these 2 groups given to government by way of these workshops, conferences, and getting people to talk about them, and ensuring that ministers are around, so that at a time when they be going for budget defense, there should be what is called dedicated budget spending, budgetary allocation for some of these biotechnological pursuits. This is what other countries do. Where you put all these budgets and you potentially remove them in order to serve their interests, I don't think that that is what we need in this country. But we cannot keep quiet. We won't condemn anybody. We will not use harsh words. But we want to say that even when they travel or when they're in the country, they look for the best meat, the best eggs, but a good many of them are imported. How can't we develop our own and use it locally, and to be cheaper and more sustainable in this country? Thank you very much.
A beautiful round of applause for the Prof. I told you, he delivered, and we're grateful for that. Prof said so many things, and of course, you will agree with me that he's a master in this game. An animal biotechnologist operations. So we're going to interact, and we're going to take on the Prof. We're going to engage him with questions, and then he will respond. Do we have questions for the Prof? Please, your mic in front of you. The microphone in front of
you. Good morning, everybody. Prof, congratulations on the beautiful talk.
Yes,
yes.
Thank you.
Yeah, I don't know whether mine is a question or a comment. It's on this issue of gene knockout.
Yeah, gene knockout.
When we're knocking out for whatever, we should also be conscious of what we have. For example, there is this breed of cattle, Kuri, found in the northern east part of Nigeria. Not east. And these animals are very huge, with very heavy bulbous horns. And these horns are actually an adaptive feature to enable them swim to cross a river. If you now knock out these genes for horns to make meat, or for whatever reason, and you lose the horns, these animals will not be able to swim. So while we are advocating gene knockout, we should also be mindful of preserving what we have. They should run pari passu. And I think this goes to say that God endowed us with different breeds of animals. And some of these animals are domiciled in different parts of this country for certain reasons, for religious reasons, for feed availability, for diseases, and so on and so forth, each adapting to a particular environment. And therefore, when we are looking out, or when we are embracing biotechnology for development, we should be cognizant of the differences in some of these things that God has given to us. I think mine is more of a comment than even a question. Thank you very much.
Thank you.
Yeah.
Thank you. Please, can we have you, sir?
Yeah. Can I respond to?
Okay. Sorry, let me take Dr. Rose. Dr. Rose?
Yeah. I'm not a scientist.
You are already.
But
Yeah,
yeah,
technologist.
but
You are surrounded by us.
I am.
It's okay.
I just want to say something about that gene knockout so that people will not be scared. And the regulation is there actually. If you knock out, you're knocking out that gene because it's of no use to you. That's why you're taking it out. And that's what the genome editing stands for. It's what, I mean, the negative effect or impact of that gene. That's why it's of no use. You're knocking it out, and you're knocking it out to make it better for the animal and then for ourselves, for our own use. And so after that, at least there's regulation. The regulation, and we have the regulatory framework in place in Nigeria. So the regulation takes care of whatever. If that gene you've taken out, it takes so many years at least for you to come out with a safe and wholesome genetically modified organisms or food or whatever. You have to understudy it. You have to study the effect, the aftermath of that gene you have knocked out. If it's tending, the results you're getting, the data you're generating, if it's tending to the negative, then you drop that project. That is right. What the regulation stands for.
Professor,
yes, yes. And then, Prof, actually, the example you gave, we're not really comfortable with it.
What is it?
Omega? Frogs.
Yes.
Using example with frog.
Just,
so someone who is
just
sitting on the borderline would actually not. It's a living system, you know, all living system. I mean, the DNA structure is the same. Those four bases, that's what we all have. You know, animals, what higher or lower animals or whatever, even the microorganisms. And even the microorganisms, if you use gene from that, they are part and parcel of the system. So it doesn't, so you know, when you mention things like that, it scares some people. Yeah.
But people eat frogs.
Yeah, Chinese eat frog. Yeah, some people, even in Nigeria, lizards. You know, people eat snakes, lizards. So it doesn't really change your genetic makeup.
From earthworms are also harvested.
Yes, it doesn't really change, you know, your genetic makeup or whatever. There's really nothing. If it's smelling fish, whatever, I mean, fish, we eat fish now. So at least some of these things, some that are still on the borderline, it scares them and they begin to say so many things. Although most of us here are scientists, but we have some media people. I hope they will not go and turn the
I was
story.
only pointing out the concerns.
Yes,
Yes, we
yes.
know, and we know. There's
I think-
some concerns, just do it diligently.
Yes,
I wanted to tell Professor Eckworth that I believe that Peter is as our pet
Please
names.
activate the
Yes,
mic.
I'm Silvanus to him.
the mic.
I am very sure that if he had his way or I had my way, I would have the gene that made me as very small should have been knocked out in me a long time ago.
Oh, me then.
So that
Yeah, you know, they are talking to me.
I'm going to be as tall as whoever is as tall. Yeah. So, all these negative things, there's now
No, she has
possibility without going to prayer houses to pray for it.
No.
You can use the laboratory to
Yeah.
That is the point.
Okay.
Maybe you took intelligence from God.
Eh,
Not the reverse. Okay, do we have any other question?
Sorry, I
No
want
problem.
to speak.
Okay, please, can we have you, sir?
Okay. Thank you, Prof. My name is Elojo Joseph Ako, Animal Husbandry Services Department, Federal Ministry of Agriculture and Rural Development. Thank you for things are new now, far from what I knew in the university in animal breeding and genetics. And that is why knowledge is dynamic. And like you caution, we must be cautious in applying technology, because the greater of all things has importance for every element in creation. And through our discovery, if we don't take time, we may shortchange ourselves from benefiting all that God wants us to benefit. He mentioned the horn. Curie, of course, you know, is one cattle that can swim.
Yeah.
And one advantage is that because the purpose, whatever,
yeah.
horns make
Follow.
it to flow.
Yeah.
If you now carry that animal and do that thing, you have disarmed that area. Then another thing is that we also have industrial use for horns, for instance. I'm just talking. Now, if you get off horns, what those benefits you get, where will you get them again? So while we are looking for meat, we are looking for milk. Maybe time now, okay, we'll not take gene from the worm and make then our animal man don't get bone again. And then we know that what we benefit from bone industrially, even in other areas of usage, now labor. So, as like there have been many uproar about GMO, and these are also outcome of biotechnology. And so many are so skeptical, especially about the crop aspect. We should be very, very careful that as we apply this, we should make a balance that it will not have any disadvantage in one way or the other, because, like I say, everything has its use at one point or the other. So, it's a good one, and I pray that we will masterly apply the knowledge that will benefit overall, no, without any area missing. Thank you.
Thank you very much. Can we have Professor? Can we have Professor Omar? Thank you.
Thank you very much. Prof, you are very delighted with the lecture. One important thing Prof talk about is the funding. Funding is very important. And all these things that we are talking about must be before the government, must be in the agenda of the government. You see, they have established institutions that can promote all these things, like NAFDA. It's an institution of the federal government, ostensibly established to promote biotechnology. But if you now go deep down, the funding is not enough to even sponsor a single research program. Prof, you have talked adequately on this. If you take the multinational companies, for instance, even the AstraZeneca that we are talking about, who are producing the vaccine that we are taking for COVID-19, when they were established, they didn't embrace, it was a pharmaceutical company just to manufacture drugs and vaccines. But when biotechnology came, they embraced biotechnology. And today is one of the leading pharmaceutical companies. They invested billions of pounds just for this COVID-19 vaccines. And they assemble well-established researchers in the field of virology, immunology, across the world. When the pandemic, when this pandemic came, just to come and produce the vaccine. And imagine as assembling notable scientists across the globe. It's investment. But they were doing this because they know at the final analysis, they will get a lot of profit out of it. So in other words, unless we invest and fund these research agencies, we cannot get much of what we expect or to contribute to the GDP of the nation. Up to this moment, we are talking about science and technology, research, innovation. We are just at the talking stage now. We have not yet gone up. I don't want to say next level. This time, using next level is another thing. But just going up, trying to see that we have properly pay attention and then fund this organization. All these noble objectives could not be actualized without the funding. When governments try to see how much it will give you, then how much does it expect from you immediately? Then it's beside the point. It's a long-term investment. When you invest, you make it a culture. At the end, the country benefits from it. I was reading in one of the articles in the newspaper, they said when the COVID-19 came, the Africans were not so much proactive as their European counterparts. I said, how can they be? When in America or United States, they invested close to $1 trillion in trying to control the pandemic using science and technology.
Yeah.
And you are here just saying we are committed to it, we are tomorrow going to give it. You see, talking cannot take us anywhere. So, Prof, we are happy with this. And I think this workshop will take into consideration about this funding. This funding must be emphasized and re-emphasized. Yeah. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Very important points being mentioned. He talked about funding.
Yeah.
And may I just add something? Synergy, building synergies. And that is why we are here. As promoters of biotechnology, NAFDA has the mandate to bring together scientists to look at national problems and see how we can do it, and how we can solve the problem together. And I believe this is one of the things that we'll achieve with this workshop, hopefully. Do we have another question? Okay, it seems that the thing is flowing towards this side. Okay, okay, sir, please, your mic.
So that we can
Okay. Problem, I'll come back to you, sir.
Roy, do quick so that we can take the next.
Okay.
Let me start. Good afternoon. Let me start by appreciating Professor Omeje for the brilliant presentation. I'm not really surprised. Prof is our leader at ABGEN. Only he refused to link ABGEN activities to the new era we are going into. And I think there is an interplay between what we do at AppGen and animal biotechnology. Nevertheless, I thank you for the exposition. The issue of funding is what I wanted to raise in my presentation. But I think I should hint the audience right from now that to expect our government to fund biotechnology, especially animal biotechnology, the way it is done in advanced nations, might constitute a disservice to humanity in this part of the world. So I think what we should do, let's take that very, very seriously and come up with ways of assisting government in raising funds. What I mean is the synergy between what we do in the academia and the industry must be strengthened. Otherwise, if we say Nigeria should fund biotechnology the way it's been done in America or Europe, I mean, we might be left with little or nothing for the millions of our population. So please, I'm imploring us, please, let's think deeply and find a way of strengthening or making the industrialists, the investors, to be interested in what we do and not necessarily depending mainly on government allocation. Thank you very much.
Yes, thank you very much. Wonderful contribution. Please, we just have 2 questions for want of time. We're progressing to the next presentation.
Yeah. Okay, sorry. Mine is just to allude to what the 2 professors have said. I think as a group now, we have a problem. 3 ministers are coming: the Minister of Agri, the Minister of Science and Tech, the Minister of State, and the Council. So it's not for us to allow them to just come and talk and go. They have to listen to us. So if we can ask the VC of Borno State University to say something like what he said, we should re-emphasize. He should talk on our behalf before the ministers do their talking, and it should be, agreed by all of us. I think it's better. It's not for them to just talk and go and not listen to the problems on ground, and that we need it. The Minister of Agri will be here. Let him listen to us, and we need implementation of some of these policies that we have. And we can move mountains, not for us to be going and importing cement and words. It's terrible. It's very terrible.
That's a beautiful suggestion. And I think with the synergy we have, imagine if a proposal gets to the minister and you have 10 different organizations talking the same thing, I guess to have more strength. We're building synergies. A beautiful idea. So Prof, will be counting on you, sir, to help us. Just 2 more before we proceed. I will take, yes, I'll take from Prof. Ari and then from my boss, Queen.
Thank you very much. But let me appreciate the presentations and positions of our professors, especially the presenter. Mine is okay. Mine is about talking directly to our chief host, NAFDA, and our partner organization. I think we need to cascade down the things that we're doing down to the levels of the university. Let me begin by appreciating the quantum of work you are doing, especially in the area of regulation. For us to be able to have the right regulatory framework, or for us to be able to have the right advocacy, we must begin with the richest pool of researchers, which are known in the universities and the research centers. I assure you, we need to be able to help support the university system, establish research ethics committee. Most grants that are available everywhere are under the requirement that you must be able to have a research ethics committee that works for you. This will be the beginning of regulation, like Prof has mentioned. If we don't have that, people can get crazy with what kind of ideas that they will have. Then the second issue I'd like to look at is the cross point. I would like to consider it as crossover point. I'm happy Dr. Rose has pioneered the the crop-based research, biotech research. One of the things that we can do to make our immediate impact is look at the area of transiting from crop to animal research, which could be a solution to a major national challenge today. Can we begin to see how we can work around animal feeds? Can we begin to see how we can work around removal of anti-nutritional factors in basic feed requirements? We all know the challenges that we're having in terms of costs of ruminant feeds today. We all know the challenges that we're having about pastures, availability of pasture. So can we do something? I know that Cuba, I had the privilege of working with the technical group in Cuba. They picked their pasture grass from Nigeria in a matchbox. And today it is a dominant pasture plant in Cuba. They picked that from Nigeria. If we begin to look at that, we are going to have an entry point into the minds of major stakeholders because we are resolving issues that matters all of us. Now, secondly, about funding. Let me share my experience. Some 5 years ago, I was in Australia and as a visiting lecturer. We had investments from first the farmers group, like Prof made mention of our fishy smell in the fish meal. Yes, it's a challenge. Can we throw it back to the scientists? It was there with, for instance, canola. The canola feed group were fighting the soybean group. What was the matter? If you feed poultry with canola, there will be a fishy smell. It's all about what? Biotechnology, removing that gene that is responsible for that smell. These are the areas that we can have as our entry point. And then again, we can see ourselves having the interest of good major groups like DSM, enzyme manufacturers, working to support you reduce the levels of anti-nutrient factors, empowers your basic oil seeds. These are our challenges, our immediate needs. We must be able to see ourselves addressing that as an entry point into the minds of major stakeholders. We must also look at budgeting as a factor. One, we as practitioners of this industry must be able to look at capital costs over and ahead of what do you call it? What's that other cost? But service costs. Instead of us, let's see ourselves increasing the value of what we need to do in building our research centers, our research facilities, rather than the motor vehicles or the travels allowance or the personal costs that's going pari passu with those costs. That will convince every investor in that sector. Otherwise, we'll not get it right. Yes, the synergy that we're building is correct. We must be able to see how we can look everyone into it. Manufacturers, academia, researchers, regulatory bodies, and end users. We must look at end users as key drivers. If we are able to sensitize them enough, looking at the benefits that inherent in biotechnology, they will invest money. Imagine Dangote challenging with what can happen if you are able to have a patent right for removing anti-nutrient factors in soya. And imagine the market for the poultry industry. Imagine that. It's a stimulant. I hope that this end of this workshop will be able to come up with ideas that will help us in this direction.
Thank you very much, Prof. It's always a nice thing when you listen to professors. And at some stage, you just lose your appetite for food because you get so much bloated with ideas. And hopefully, they will translate into reality. This is the beginning of new things to come in Nigeria. And we'll get it right. Amen.
For sure.
Please, can I have...
If you have questions, sorry for... You have questions, you can write down.
Okay. I think we just take one more. Okay, any other questions?
Just write your question.
I'll take one more physically, then please write the others. The scrimmage. Go ahead.
Thank you for the time. We are very for the presentation so far. On the issue of milk dairy production, now there's already working with SMAP Farm, Ibadan.
Okay.
And the pattern of livestock and honey husbandry on the milling problem. And part of we have achieved a production of 50 liter to 70 liter per day. And we have intention of replicating those centers and assign to other regions of the country. As well, the beauty part of it is that the plants that are there, they're using the technology, and there's a market, there's uptake market from there, from Friesland, Nigeria Limited. So I think the best thing is that we have to link our innovations to induce risk to market. That's very important. And also, I remember there was a time that one of the functions of Rome and the Moon Council is to be able to collect 2% of each of the companies that have related activity with agri. Then it should be gathered by Rome and the Moon Council. Then they will be helping those sectors, like in Roba, a 2% something to be given from Machilin before when they are here. Then Rome will collect the money, then the support activity in Roba activities, which is a 1 nari. And again, another problem when you can see out of 10 science suit. It's a Nigerian science suit only for the animal based, something which 15 college of agriculture, we have more crop